Dear viewers, in this video we are going to understand about simple moving average. So what exactly simple moving average is? Simple moving average is a method of calculating the average of a data set over a specific period. The purpose of we calculating moving averages, we want to smooth out the short-term fluctuations by averaging the data points and understand the long-term trends and patterns. This is what we mean by simple moving average. So let's understand what is the formula for simple moving average. The formula for simple moving average SMA is nothing but you need to add the number of data points and divide the number of data points with a specific period. What do we mean by this? Let's understand this with the help of an example. Then I will also explain how the same can be calculated in an Excel file. First we will understand this example, then I will take you through the Excel file and we will understand it with the Excel example. Here I have a set of data points and these set of data points are collected in a chronological order. When I say chronological order, it is collected with respect to time. So I have 45, 50, 45, 60, 55, 42. These are all data points. Now I want to calculate moving average with n is equal to 3. What do we mean by moving average with n is equal to 3? So if you see the first three data points, 45, 50, 45. So when I add 45, 50, 45 and divide by 3, what I get is 46.67. So this is the value that I get by adding the first three data points and then dividing it by 3. And if I want to move the word moving average, if I want to move this, I need to move it by one number. What do I mean by moving this average by one number? I am now adding data point 2, 3 and 4, 50, 45, 60, and then I divide by 3 and I get 51.67. Again I moved by one more number, so now I am going to add 45, 60, 55 and divide by 3 and I get 53.33. So this is what we mean by moving average. I decided to move my average with n is equal to 3. You may ask me, Vinod, why 3? Why not 5? Why not 7? So the moving average n. So should I have to calculate this moving average for 3 or should I have to calculate it for 5? Should I have to calculate it for 7? That is dependent on the industry for which we are doing this moving average. So that n can be 5, that n can be 15, that n can be 30. Depending upon which industry we are doing this analysis, we can move the number by the respective value. So here 3 is a good enough number for me to do the moving average. In some other place it could be 5, in some other place it could be 15. So depending upon where we are doing this analysis, we can do this moving average for a respective n. And when I repeat this exercise for the following numbers, the three numbers get added and then we divide by 3 and we report the moving average. So what you see here is the moving average, and whenever you try to plot this data in a graph, if you are taking n is equal to 3, your actual data point will start from 45, 50, 45, whereas the moving average will only start from the third number. In this case, third number, because n is equal to 3. Whereas if you take 5, then for the first 4 data points, you will not have the moving average. You will have the moving average only from the 5th data point. So in this example, what you see in the last column is what we call it a simple moving average, right? So conceptually, I hope you understood what we mean by simple moving average. So we decide to take average for a particular set of number. Here that particular set of number is denoted by the alphabet n, which is nothing but the window size or the period for which we are doing this moving average. So this is the conceptual understanding. Now let's go to Excel and we will understand how it works in Excel. So the same data points I have here, what you saw in our PowerPoint presentation, I have the same data point. So here 1, 2, 3. So at the third data point, I'm going to say is equal to, and I'm going to say average. I'm going to select average and the first 3 data points. Now if I copy this average formula and if I copy it and paste it in the next column, you will find the average, and if I double click on this, you will understand it is for data point 2, 3 and 4. Similarly, if I repeat this exercise for all the data points, I'll be able to get the moving average. And what is the data here? So this is moving average for n is equal to 3. Now why moving average makes sense? Let's understand. So whatever be this data, if I try to draw a trend chart for this data, if I try to draw a trend chart for this data, the data looks like this. Let's adjust the scale so that we get a sharper view. I go to format axis. I don't have any data point below 40. So I'm keeping my minimum value as 40. or we can keep 35 to have better view. And similarly, I don't have any data point above. Yeah, automatically it got adjusted, right? So here you see the trend of the actual data point, right? Now this trend of the actual data point is showing a lot of fluctuation because there is a lot of variation in the data. As we saw in the definition, the purpose of we calculating moving average is to smoothen the short term variation and to get a picture of the long term trend and pattern. So here, if I extend this graph for the moving average also, so the graph is extended for moving average. Now you will find the orange color line is showing you the 3-day moving average, and the 3-day moving average correspondingly have less variation compared to the original data. Just to make you understand, let's also do the 5-day moving average. If at all we want to do a moving average with n is equal to 5, what will happen? So I will calculate my average only from the 5th data point. So the 5th data point will be somewhere here. So I say is equal to average, and here I select the first 5 data points. So this is average of the first 5 data points. Now I can copy and paste this formula for all my cells, right? I can, and if you get like this, the reason why is there is an inconsistency in the formula. So if you get something like that, you can say ignore error. And similarly here also we can say ignore error. The reason why we say inconsistency, because it is taking the next three numbers or next five numbers, so that is why Excel assume there is some inconsistency in the formula. So now I have calculated simple moving average for n is equal to 5. Now if we extend this graph, let's understand this. If I extend the graph, we have the actual data point, which is the blue color curve, and then we have the simple moving average with n is equal to 3, where I have an orange color curve, and then I have a simple moving average with n is equal to 5. So the graph starts only from the 5th data point, and that is the, let me change this for a better color so that it becomes easy for you to understand. So let me give a dark green. So the dark green color that you see here is the 5-day moving average. So you have a 3-day moving average, you have a 5-day moving average. So depending upon which is more relevant, we will be able to plot that particular moving average. And what does it do? It actually smoothens the short-term variation. It helps to give you a long-term picture about your data. So if we want to understand where this is being used, let's understand that in the used cases. So generally in financial markets, moving average is used to smoothen out the stock prices or market indicators to identify trends over a time. So in many of your financial articles, you will understand terminologies like 20-day moving average, 30-day moving average, 50-day moving average. Similarly, in a quality management perspective, moving average helps to monitor production quality by averaging defect rates or performance metrics over a period of time. Similarly, in forecasting, one of the places where moving average have a significant usage is in your time series analysis and forecasting. So when you are trying to do a demand forecasting, simple moving average will help you to smooth out the fluctuations in the demand for a product and providing a clear view of what is the underlying trend. So in forecasting of demand also, we can use a simple moving average. And similarly, in sales analysis, we can use simple moving average to evaluate sales performance and identify seasonal trends. So these are different places where simple moving average can be used. The advantages of using simple moving averages: one, it's simple, the formula is easy to calculate, interpretation is also very straightforward, easy to interpret. So as we saw, the application of simple moving average is also easy and being applied in many places. But simple moving average also have some kind of disadvantages. And what are the disadvantages? It assigns equal weightage for all the data points. So the weightage of older data points is equal to the weightage of recent data points. So then what happens is it does not really tell you what's going to happen considering the very recent data. So that is one disadvantage that we have. And similarly, there is a lag in the simple moving average. And what we mean by lag, it does not react quickly to sudden changes. That means if there is a sudden change in the last 2-3 data points, it does not react quickly because it gives equal weightage for the older data points as well. So considering all these things, there are certain times where we need to move away from simple moving average. So as part of this series of videos, we are planning to cover what is weighted moving average, what is exponential moving average, and various other methods of using moving average. So we will cover those one by one in our upcoming videos. In the first video of moving average, I hope you all understood what is simple moving average, how it is calculated in Excel, and what is the conceptual understanding of the formula, and the usage of simple moving average, and the pros and cons of using simple moving average. Hope this video was useful. For more videos on data analysis, quality management tools and techniques, please subscribe to our channel. Thank you.